In this video, I'm going to be talking about the limits of trigonometry function. And whenever we are asked to find the limit of trigonometry function, it's actually very, very simple, but the most important point that I want you guys to take note of is actually, I want you guys to note two things here. That whenever we are given limit, right, x approaches 0 of sine x, right, divided by what, x, this is going to give us what, 1. And at the same time, whenever we are given limit x approaches what, 0 of tan x, right, divided by what, tan x, this as well is also what, 1. So these are the two things I want you guys to take note of, because it's just like let me just call it identity actually, because it has been proven that limit x approaches 0 of both sin x over x and tan x over x will always give us what, 1, right? So this x that you are seeing here, that you are looking, this x actually represents what, an angle, right? Is a just like it represents an angle in what, in radial form, right? So let's go ahead and see the first question that we're going to add here. Suppose we are asked to find, let me say, we are given limit, right? And in this case, we have the value of x, limit, let me say, x tends towards 0 of, here we're going to have x cos x, where was, let me say, sin x. So now if you look at this trigonometric function and we are asked to find what the limits of this trigonometric function, it's actually very, very simple. But what we are going to do is just to, since we are having single denominator here, I can actually separate, so that I'm going to have this to be, x divided by what, sin x, right? Then multiply what, cos x, right? So if I go ahead and find the limits separately, I'm going to have limits x approaches what, 0 of x divided by what, sin x, right? Then here is going to be multiplied by what, limit x approaches what, 0 of what, cos x. So, and if you look at this side very well, I can actually apply the NC on this side, because whenever I'm having limit x approach 0 of sine, you can recall, you can actually recall that whenever we have limit, right, of x approaches what, 0 of sine x divided by what, x, that's going to give me what, 1. And if I go ahead and take the reciprocal of what, of this side here, I'm going to have it to be, taking the reciprocal, I'm going to have it to be x over what, over sine x, and this is going to give me 1 over what, over 1, which is also the same thing as what, 1. I hope you guys understand what I did here, just to take the reciprocal of what, of this, or this particular function that we're seeing here. So then go ahead and put it here, because that's exactly what we need for this guy here. So we're going to have it to be, let me see, we're going to have this to be limit x approaches 0 of x over sine x. This is going to give us what? That's going to be 1, right? Because if we take the reciprocal of the identity that we have here, we're going to have it to be 1. Then multiply what? Limit cos x, which is going to be what? Cos in the bracket what? 0. And cos 0 is actually what? 1. So I'm going to have this to be what? 1 times 1, which is actually what? 1. So taking limit of what? Of this function that you are seeing here, the final answer is actually what? 1. Now let's look at another question I'm having here. We have limit x approaches 0 of cos x minus 1 divided by what, x. Now in this kind of situation, what I'm going to do is just to go ahead and rationalize, right? And if I'm going to rationalize, I'm going to rationalize with respect to the opposite sign of what, of the numerator. So I'm going to have this to be multiplied by what, by, here is going to be cos x, right, plus 1 divided by what, cos x plus what, plus 1. Then let's go ahead and see what you're going to have in this situation. I'm going to have this to be equal cos x minus 1 in the brackets cos x, right, minus 1. Then divided by what, I'm going to have this to be x cos x plus 1. That's what I'm going to have. So the next thing I can go ahead and to do here is actually to, let me simply say, open the bracket here. And if I'm opening the bracket, I'm going to have cos squared x, right? Then here I'm going to have it to be what? To be minus cos x, right? Then again, I'm going to have minus what? Cos x again. Then I'm going to have plus 1. That's what I'm going to have. Then all divided by, I'm going to have s cos x plus 1, right? So from here, what is I'm going to do, I'm going to simplify a little bit. I'm going to have cos squared x, right? Then minus what? 2 cos x, right? Then plus 1. divided by what? X cos x plus 1. That's what I'm going to have. So from here, what do you think I'm going to do? Right, I can just go ahead and rewrite something in another form, because if you look at this very well, I'm having cos square x, right? Then here at the same time, okay, sorry, this should be plus 1 rather. This should be plus 1, and if this is plus 1, this is going to be plus. One of these is going to cancel each other, right? They are going to cancel each other. That's why this and this will cancel each other actually, right? Because it is plus. This should be plus rather, because I'm rationalizing it with plus, not minus. So from there, if that's the case, this is not part, right? I cannot have something like minus 2 cos x, right? So I'm going to basically have this to be what? To be plus 1, right? And in that case, I can actually go ahead and use trigonometry identity here. I can basically use what? Sine square x, I can recall, plus cos squared x to be equals to 1, right? That's what I'm going to have. Then if I'm going to make cos x out of formula, right, here should be a minus actually. Sorry, what kind of mistake is this? This should be minus, not plus, right? So I should have this to be what? To be minus actually. And this is going to be minus, right? As well, this as well is going to be minus, not plus, right? So it's going to be minus, not plus. That's what we're going to have. So from here, if I'm going to use trigonometry identity, I'm going to have this what? To be sine squared x to be equal to, here is going to be 1 minus what? Cos squared x, right? And if you look at this very well, I can now rewrite this guy in form of what? Of this. That would be by factorizing what's negative. If I'm factorizing minus from what? From this, or from what I actually circled, I'm going to have it to be, from here I'm going to have it to be, this is going to be minus cos squared x plus 1. And that's basically what? 1 minus what? 1 cos square x minus 1. That's basically what it means. So if I'm factorizing minus here, right? So this is what, that's exactly what I'm going to have. Let me just rub this side and just try to simplify a little bit, because to avoid mistake again. So let me just see what I'm going to have in this picture, right? So that's what I'm going to have. So from here, since I actually want to make use of 1 minus what? Cos squared x, and here from here I actually have what? Cos squared x, right? I actually have cos squared x, right, minus 1. Then divided by what I'm having is x cos what? Cos x plus 1. So if I'm going to put this guy here, I'm going to replace it. I'm going to have factorized minus here, and if I'm factorizing minus, I'm going to have minus cos squared x plus what? Plus 1. And this basically 1 minus what? Cos x divided by what? S cos x, right, plus what? Plus 1. So if you look at this guy and this expression here, they are quite the same thing, right? Because if I write this guy here, I'm going to have 1 minus what? Cos squared x, right, divided by what? X cos x plus what? Plus 1. That's what I'm going to have. So what do you think I'm going to do in this kind of situation? I can actually go ahead and write this as what? As let me basically say I'm having it as, here is going to be sine squared x divided by what? X cos x. This x actually is multiplying everything here at the same time, right? So I'm going to have x into brackets cos x plus 1, right? That's what I'm having, right? So let's just go ahead and simplify this expression a little bit. So looking at this, what I'm going to do here is actually to go ahead and, let me just say, simplify, or let me separate actually. If I'm separating this guy here, I'm going to have it to be, here is going to be sine x, right? Divided by what? Divided by x. I'm separating, right? So if I'm having sine x divided by x, I'm going to have this to multiply another sine x again, right? Divided by what? Here is going to be cos x plus 1. I think that's what I'm going to have. So from there, I can actually go ahead, whenever if I'm going to take the limits of this side here, if I'm going to take the limits, let me just basically cut this one off. So if I'm going to take the limits, it's actually very, very, very simple, right? So I just need to record the identity, right? That whenever I'm giving, I'm asked to find what? The limit of sine x over x. That's going to give me 1 directly. So I'm going to have 1, then multiply by what? Sine x divided by what? Here is going to be cos x plus 1. Now, what do you think I'm going to do next? Because this is actually very simple. I can actually go ahead and substitute the value of what? Of x, right? And in that case, I'm going to have this to be 1 multiplied by what? Sine 0, right? Divided by what? I'm going to have this to be divided by what? Cos 0, right? Plus what? Plus 1. And in that case, I'm going to have this to be equal. 1 multiplied by what? Sine 0 is actually what? 0. Divided by cos 0 is actually what? 1 plus 1. That's going to be 1 multiplied by what? 0 over 2. And this is going to give us what? 0. Right? Because 0 divided by 2, that's actually what? 0. 1 multiplied by 0 is actually what? 0. So this is going to be the what? The limit of the function. So that's exactly what we are going to have. So let's go ahead and solve another question. So let's look at the question I'm having here. I'm asked to find the limit of tan x divided by sine 2x as x approaches pi. And what I want you guys to understand here is that whenever we have pi simply means 180, right? It's an angle and it's actually 180. Pi is basically 180 degree. It's actually an angle. So now let's take a look at that way we are going to solve this question. So I can actually record that whenever I'm having tan x, right, I can write it as what? As sine x divided by what? Cos x, right? That's what I'm having. And then whenever I'm given sine 2x, I can write as what? As 2 sine x cos x. Now one thing that happened here is that if you're not familiar with this identity, you can actually pause this video and watch my video, the video I make on trigonometry identities. Right, you're going to see all this function there and how we actually arrive at this 2 and x cos x. Right, so you're going to see it there. Now let's continue. Here I'm going to replace everything that you're seeing here with the new expression I'm having, so that I'm going to have this to be sine x divided by what? Cos x, right? Then I'm going to have divided by sine 2x is basically 2 sine x, right? Then cos x. That's what I'm having. So if I change this guy to what? Let me say multiplication sign. I'm going to have this to be sine x divided by what? Cos x, right? Then multiply by what? I'm going to have 1 divided by what? 2 sine x, right? Cos what? Cos x. That's what I'm going to have. So what I'm going to do in this kind of situation is just to go ahead and what? And let me say simplify this expression a little bit, right? Because from here I can actually have this to be, this can actually cancel this out, right? And I'm going to have 1 divided by what? Here is going to be 2 cos squared x. That's what I'm going to have, right? So, and then what do you think I'm going to do in this kind of situation? Right, if I'm having 2 cos squared x, and let me just apply the limit here. I'm going to have limit x approaches pi, right? Of here is going to be 1 divided by what? 2 cos squared x. So here I'm going to have it to be 1 divided by what? 2 cos squared pi, right? And I said pi is actually 180, and if you find cos squared 180, that's going to be actually cos 180 is actually minus 1, right? And here I'm going to have 1 divided by 2 into brackets minus 1 all squared. That's what I'm going to have. And that's so that I can have the final answer to be what? To be 1 divided by what? 2 into brackets what? 1, because minus 1 squared is actually what? 1. And that shows that the final answer is going to be 1 over 2. So the limit of the function of tan x divided by sine 2x is actually what? 1 over 2. And that's going to be the final answer. Now let's go ahead and see the next question I'm going to have in this case. So let's take a look at another question I'm having here. The question says find limit tan x as x approaches pi over 2. Pi over 2 in this case is actually 90. Because it is 180 divided by 2, and that's going to give us 90. So what we are going to have is just to write this tan x in the form of sine x, right? Divided by what? Cos x, right? So and if you are writing it and we go ahead and substitute the value here, we're going to have this to be pi over 2 is actually what? 90. So I'm going to have sine 90, right? Divided by what? Cos 90 in this case. So in that case, sine 90 is going to give you 1, and then cos 90 is actually what? 0. So here is actually what? Undefined, right? So that's why the limit of this function is actually what? Undefined, right? So as far as x approaches pi over 2, the limit is actually what? Undefined. That's exactly what we have. So now let's go ahead and solve another question. Suppose we are asked to find what? The limit, right? We are asked to find the limit of a value, let me say, of s squared, right? Then sec x divided by what? Let me say we have sin x here, and then the value of x approaches what? 0. Now if I ask to find this limit, it's very, very simple. what we just need to do is just to go ahead and what, and separate. And if I'm going to separate in this kind of situation, I'm going to have x divided by what, sine x, right? Then I'm going to have multiply by what, let me simply say I can have another x. This is going to be x sec x, right, divided by what, here is going to be what, sine x, right? So that's what I'm going to have. So what I'm going to do in this case is actually to go ahead and rewrite sec x, right? If you can see, this sec x is actually something, and sec x is actually what, 1 divided by what, cos x, right? So that's what I'm going to have the sec x to be. And then the next thing I can actually do is that let me just say, actually I'm not going to have another sine x here because I'm just having a single sine x. So this will be ordinary sec x. So if I'm having ordinary sec x, in that case I'm going to have this to be, let me simply say, here is going to be x divided by what, sine x, right? Then multiply by what, here is going to be 1 divided by what, cos x. So I can actually go ahead and take the limit as x approaches what, 0 here. So that's just that if I'm taking the limit, I'm going to have this to be x divided by what, sine x. If you remember, if you guys recall earlier, I said whenever we take the reciprocal of this guy here, if you take the reciprocal, it's still the same thing as writing x divided by what, sine x, and that's also what, 1 divided by 1, which is also what, 1. So if I'm going to take the reciprocal, that's that everything that we're having here is actually going to be equal to what, 1, right? I'm going to have 1, then multiply what, 1 divided by what, cos x is actually what, cos 0, and cos 0 is actually what, 1. So I'm going to have this to what, 1 multiplied by 1, and that's going to be equal to what, 1. So the limit of what, of this value here is actually what, 1. So that's what we have. So the next thing that I'm going to do here is just to solve one more question, right? And then that's going to be the end of this video. So let's go ahead and solve one more question. So now let's take a look at the last question I'm going to have in this video. So we are asked to find the limit of function cos x sine x divided by sine 2x. This question is actually very simple, right? Because one thing I need to take note of is that I can actually apply trigonometry identity for one of them to one of the what of the value here, right? Or trigonometric value here. I can actually apply it to sine 2x. And if I recall, I'm going to have sine 2x to be equal to sine x cos x according to trigonometry identity. That's what I'm going to have. Then I go ahead and put it on this side. I'm going to have cos x, then sine x, right, divided by what? Here is going to be 2 sine x, right, then cos x. So if I try to rearrange here, I'm going to have this to be what, to be cos x sine x, right, divided by what? I can rearrange it to be what, to be 2 cos x, right, sine x, right? So that's what I'm going to have. So what I'm going to do now is that I'm going to cancel one of these out because this is going to cancel this. Then I'm going to be left with what, with 1 divided by what, 2. So that's basically what the limit. It's very simple, right? Once you know the identity, to solve trigonometry function, to find the limit of trigonometry function is actually very simple, right? So you just have to know the trigonometry identity that we have. So that's all it's about this video. If you enjoy it and you find it helpful, don't forget to like, share, and make sure you subscribe. It's very important. And please do wait to share my video to your friends, right? So that's going to be the end of this video. Thanks for watching.